Hello friends, welcome back to my channel, and today we are back with another exciting course. So as you can see on the screen, this will be a complete Docker course. So this the motivation behind this course is like I have done a tutorial on Jenkins, and I had created a complete or full course for Jenkins in 3 hours, and that has been welcomed by all our community members, and it has been used by a lot of colleagues, and I got a really good feedback. So there have been a lot of requests on creating similar kind of full courses on different topics, and due to the time consumptions and the effort I have to do this, I did not got time to start the other course. So I already have a lot of tutorial on Dockers with short videos. So what I'm going to do in this tutorial, I'm going to have a complete course on Docker, and that will be taking few hours. So it will be a long tutorial, but don't worry, you can pause the course, you can save this. I will have complete detail described in this course, from what we are covering and ending until what stage. Okay, so this will be a complete course on Docker for beginners. So this Docker tutorial for beginners, it's not only for beginners, I will say, like whether you're intermediate or may not be as a high advanced, but we'll be talking about the advanced topics like Docker Swarm, Docker Stack, and all those things also in this tutorial. So it's not a complete beginner course, but as a beginner, this course will give you a complete knowledge starting from a beginner to reaching till end of becoming as an intermediate or advanced Docker expert. So let's get started on the agenda. So in this complete Docker course, we'll be covering the end-to-end topic. So if you go through some of the paid courses in Udemy or some other plural site or other course tutorials, you may not see this complete course which I'm going to cover, because a lot of topics they will cover only really basics of what Docker. But in this tutorial we are going to cover in depth, not only the basics, we'll be also talking about Docker Stack, creating Docker services. You'll also talk about what is Docker Swarm, how to set up Docker Swarm, and all those things. So let's go through the agenda. So what we will do is, like, we will start with the basics. So we will have a discussion on what is containers. So we need to understand what is containers, what is the difference between traditional model of setups, what is container setup, what is a virtual machine setup. So those kind of basics we will discuss. Then we'll also talk about what is Docker. So once you know about containers, it will be easy for you to understand why we are using Docker. And we will also set up Docker on a machine. So there are different ways you can do it. You can set up Docker on Linux or Windows or Mac. So different kind of scenarios to set up Docker. So we will talk about how you can set up your Docker on different kind of environments. So depending upon your use case, you can set up your Docker. So once you have the Docker set up, we will see like how you can create your container. So we will run our first containers, and when you run the containers, then we will talk about, before getting in depth on the Docker commands, we will talk a little bit about what is Docker image and containers. So we need to understand the Docker image, what are the different kind of layers, how the Docker image is getting created. So those kind of things we'll be discussing as part of Docker image. And we will also talk about Docker Hub or different kind of other Docker registries. So not only Docker Hub, we will also talk about private registries, how you can create Docker registries, those kind of things we will also talk. And I'll be giving a lot of references in this tutorial. So some of these topics which I don't cover directly, what I will do is I will refer you to a link in my course itself, because I have a lot of tutorials on Docker in my channel itself. So I may not repeat high-end some topic, but I'll be referring you to some video which you will be able to get the complete extended details if you want more information on that. But I'll be covering most of all the topics in hands-on here itself, so you can see all those topics here itself. And we will see the different kind of Docker commands which we use in our day-to-day activities, so the basic Docker commands we will see. And as part of Docker debugging and the interactive mode, you will see how you can debug some of Docker setup, Docker logs. You'll see how you can connect to a Docker containers and analyze something, and some of key concept on Docker volumes and persistent storage, like why we need persistent storage, how you can use Docker volumes on or mount points. So all those things we will see, and all these things I'll be having hands-ons as well, so we can show you like how this is done. And also we'll talk about Docker networking, different kind of Docker networks, and how you can create a network, how you can attach a network. So all those kind of things we will discuss. And also we'll talk about Dockerfile. So Dockerfile will talk about the basics, like how you can create a Dockerfile, why, and what are the different kind of structure in a Dockerfile, like what kind of commands you use. So those kind of things we will discuss. And also we will see using a Dockerfile how we can create a custom Docker image using those Dockerfile. And then we will see how you can tag this Dockerfile to your Docker Hub ID, and then how to push that to a Docker Hub. So all those things we will see in this tutorials as part of this Dockerfile and Docker image and pushing to Docker Hub. Then we will move on to a little bit complex topic on Docker Compose. So we will set up Docker Compose in the machine. We had Docker install, so we have to install Docker Compose. So we'll set up Docker Compose, and then we will also write the YAML file using in a Docker Compose file, so that we can build a multi-container application using the Docker Compose file. So we will see how to write that and what are the different kind of parameters using in the Docker Compose file. And once we complete the Docker Compose side, we will go a little bit on advanced side, like a Docker Swarm. So we'll talk about Docker Swarm, why Docker Swarm is used and what is the reason for that. And we'll also see how we can set up a Docker Swarm. So we will set up a Docker Swarm setup using multiple nodes, and then we will see how to create a service in Docker Swarm. So we can create a service, so that we will see how the service is running on different nodes, and the different replicas we will create of those service. And then we will move on to the Docker stack basics. So we will also talk about what is Docker stack and why we are using it, but I will not go in depth on Docker stack because I have other tutorials on my channel which I have shown you how to use Docker stack for high availability, different kind of auto deployment. So all those kind of things I have showed it in my channel, so I will refer you to that links which I will give into this video description as well, so you can make use of that. Okay, so but as far as you see, this is a complete course, and we are going to cover from basics of Docker, like what is the containers, Docker, what the different comparisons between virtual machines, traditional setup, how to set up Docker, how to talk about images, how to create your own image, how to tag it, how to push it to Docker Hub, how to create different kind of containers by using different commands, the Docker network, and the persistent storage. All those things we are covering. Docker Compose, Swarm introduction, and cluster creating cluster, Docker stack. So all those things are covered as part of this. So let's get started on the topic. So before I get into the hands-on, I would request you, like if you are new to my channel or if you have not subscribed to my channel, click on the subscribe button, and also click on the like button, and also give your feedback in the comment section. So give your feedback so that I can work on it, and depending upon your feedback I can also plan other tutorials in going forward. So let's talk about what is container. So this would be your basics on to understand the Docker and why we are using Docker. So to give you a simple statement, so container is a standardized portable packaging for your applications. So what do you mean by standardized, or what do you mean by packaged your application, or portable package your application? So in order to explain that, to just give you a expanded form of that, so a container is a standard unit of software that is packages up your own code of that application, and also its dependencies, so that the application runs quickly and reliably from one computing environment to other computing environment. So what does that mean? Like you have a application, maybe you have a Node.js or Angular, or some kind of web application, you consider that. So what you will have your complete code, right? Node code. You'll have a package.json file. You'll have your view files. You will have routers. You'll have different kind of files for your CSS files. You will have different files for your whole web application, right? So now what you have to do is you have to package that. So you take all those code of your application, and in order to run that application, you may need some dependencies, right? You may need some Java dependencies, or you may need some other dependencies for Node, or you may need some dependencies for HTML, or some kind of dependency you need for that, right? So what you will do is you will add that dependency also into that package, and you need some script or something customization. You will add all those things into that package, and you will completely package that software. So once you have that package, what is the benefit is, like, you can run that package simply, so that your whole application will run quickly, and also it's run on this computing environment. You can just use that package and you can run it on a other computing environment. So it will be the same package. You're not going to edit anything, so you can simply run that. So that is the concept of container, that you package your bundle your application code together with your related configuration files, or libraries, or dependencies, all those things required for your app to run. So that is the concept of container. Okay, and what is the reason for this container to come up? So if you see the problem of different cases, what we see is your application will be failed to run correctly, and the main reason arises is, like, there is a difference in configuration of your underlying library requirements or dependencies, like that. So what will happen is, like, you are running your application on one system. That system will have different kind of softwares install, or some kind of configuration change, and if you run it on a different machine, that will have a different kind of setup. So if you run on this machine, it works, doesn't mean like if you run on a different machine it will work, because both these machine will have different kind of libraries or different kind of dependencies installed. So that will be the main reason for the application to fail. So what happens is, container addresses all these problems, providing this lightweight immutable infrastructure for application packaging and deployment. So we package this whole application so that it's a lightweight immutable infrastructure as a package. We can run it on any kind of environment. So let's talk about the same thing in a different kind of pictorial representation. So before containers, so like let's go back a little bit the previous years. So where we are not using containers, what will happen is that you are a developer, or you are doing some kind of application development, right? And you have an app. So what you will do, you will have an app run, or you'll have the dependencies for that app, or you'll have configurations. So what you will do is you install that app on a laptop or server or something, right? So that server, you will also install the dependencies for that app. You will also do the configuration changes and all those things on that machine, so that your application or app one will run, right? So that will be the stable or simple scenario in the previous years, where you'll have a simple setup where you have your server or your laptop or your test machines, anything like that, where you have your app one and your dependencies, configuration, everything are done, and your application is running. Now what will happen is, like in these scenarios, like when if you want to run the same app on a different machine, that machine also should be having the same kind of dependencies, configuration, and everything, right? If something is wrong there, your app one will fail. Now what happened is, after the concept of containers, now again you are as a application developer or something, what you are going to do is you are going to bundle your app one along with your dependencies, configuration, script, everything together into a package. So what will happen is, that package already have all those things. So irrespective of your system, whether it's have that dependencies or configurations or anything, you don't have to worry. Once you run this container on that machine, your application will run, because that dependencies, everything is already available in your bundle or package, right? So that's the concept of containers, and how it was done before containers and what is now after containers, and the benefits, as I told, like, you know, these dependencies and everything causing these problems, this immutable structure which we are now done with these containers, it's easily run on irrespective of your environment or what kind of operating system. We are able to easily run our containers there. Now we understood what is containers, right, and why we are using containers. Now let's talk about a few differences about containers and virtualizations or VMs, right? So what is the difference on traditional setup and how our servers look like, right? So in a traditional server system, what you will have is you will have a hardware, right? On top of that, you will have a host operating system, and you will install your app, right? So you will have HP server or Dell server or something where you'll install Linux or, you know, Windows, and you will run your app on that server, right? That is a traditional web server or some kind of servers we run. Now what happened is after development of different technologies, we had something called virtualization, right, where you will have again the host, right, and you'll have the host systems for virtualizing your hardware, right, and you will have the hypervisor on that. So your hypervisor will convert your host into like a virtualized host where you can create multiple virtual machines, right? So using that host system, you will create virtual machines where on the virtual machine you will be running your operating system. So the guest OS, maybe one system can be running with Windows, so one system can be with Linux, one can be with the Mac. So each virtual machine can be run on different guest OS, right? And you will have the apps installed on those virtual machines. So those all machines are completely isolated, and it's like a different setup, right? That's how the virtualization works. Now this guest OS, it's a complete different OS, and it does not have any relation with the host operating system which is running on your actual hardware, right? So that's how the virtualization works. Now where in case of containers, what will happen is you have your hardware, right, and you have your host operating system. Now what we are having is like on top of your host operating system, like we'll have some kind of software to which we will talk, like we are going to talk about Docker, which is we'll be using to create containers, right? So there are other setups as well. We will be talking more about Docker in this not more, it's completely a Docker course, so it's a full course on Docker, so we'll be talking about Docker in this course. So as you can see on the host operating system, what we are going to use is we are going to use some of the kernels and the supporting files, runtime files from the host, which will be used for your containers, right? And you'll have your apps on that, so it's like a package, right? So you'll be creating containers on your host operating system, which will share some of the host kernels and some of the files to run your app, right? So that's how you will be using containers. So you can run multiple containers on your host, which will be sharing some of the files from your host operating system. So that's the concept of containers, or the traditional servers or virtual machines, right? So there is a difference between that, and why we are now using containers, which is a little bit isolated setup where you'll be bundling your application and you're running on your system, right, where it will be sharing some of the files from the host as well. Now let's talk about some of the difference between virtual machines and containers. So in virtual machines, as I mentioned, it's the guest OS which we are running on virtual machines is completely isolated from your host operating system, right? So you can run whether Windows or Linux, Mac, or any kind of operating system on your virtual machines. It does not care about the host operating system, and this is completely isolated between two VMs as well. Whereas in containers, this typically provide a lightweight isolation. So it's not a complete isolation, it provides a lightweight isolation from the host and other containers. So it uses some kind of relationship between your host and the containers, because it uses some of the system files for running your containers, right? And you you can run a complete operating system. So in your virtual machine, you're running actually a complete operating system, including the kernel. Through using that, you can require more system resource, CPU, memory. Everything is used for the complete operating system. So as I mentioned, your virtual machine is completely isolated, like your laptop or servers or something, and you're running that completely on that virtual machine, right? Whereas in the containers, the user mode portion of an operating system and can be tailored to contain just need a service for your app or fewer system resource. So what we are going to use is like this operating system on your host will have some kind of relationship, and it's tailored to use the necessary services for your app. So it's only use what is necessary for running your containers. Now in virtual machines, you can run any operating system inside the virtual machines, whereas in containers, containers are running on the same operating system version on the host. So we are not running an operating system on containers, whereas the operating system on the host remains the same, but in the container it uses some of the kernels and everything from the host. So the operating system on the host remains the same, and the container is using that. Now whereas in virtual machines, we most probably uses that for monolithic applications. So we install your application on the servers or virtual machine and we run it. So there is no big concept of microservice in virtual machine, whereas in containers it's more used for microservices or cloud native applications. So containers are mainly used for microservices, so that we can easily create our huge setup where we'll have small setups of your application splitted into small portions, which you can run it as a containers. So that's the basic concept of virtual machines and containers. Let's move on to what is Docker now, because now we are able to understand what is containers, what is the difference between a virtual machine, what is the difference between a traditional server to a container setup, right? And why we are using all those things. Now let's talk about what is Docker. So Docker is an open source platform for building, deploying and managing containerized applications. So in order to run a container, so Docker is a software which gives us that opportunity to run containerized applications on different kind of operating system, whether it's a Windows or Linux or Mac. We install Docker on those machines so that we can run containerized applications there. So Docker help us to do this building, deployment and managing of containerized application. So Docker is one of the application. There are other applications as well, so you can use any of those which you prefer useful for you, but this course is on Docker. So this Docker software or software platform allows you to build, test and deploy your applications quickly. So since we are running your application as a containers, we can easily and quickly deploy our application. So as we discussed about containers, Docker packages the software into standardized unit called containers, right? That have everything the software need to run, including library, system tool, code and runtime. So we know like what is a container, right? It's a standardized your packaged application that will have your library, system tools, codes and everything, right? So that Docker help us to run those application of your packaged application as a container. So that's a simple things which there is no much complicated thing. So Docker containers can run anywhere. It can be on premise in the customer data center, or it's done on an external service provider or on the cloud. Any places we can run containers. So once you package your application, as I mentioned, irrespective of your system, you can run Docker containers, right? Because that's the benefit of running the immutable containers. Now let's talk about what are the different kind of components in a Docker, right? So Docker, we need to understand like how the Docker works. So the core component of Docker consists of like Docker engine, Docker containers, Docker images, Docker CLI, Docker daemon. So these are different components in Docker. So we will talk about all these things in the upcoming part of this tutorial. So these are some components which you need to aware, like what is the Docker engine, what is Docker containers, what is Docker images, Docker CLI, Docker daemon. So what is a Docker engine? So Docker engine is a part of Docker which create and run the Docker containers. So it's a base of Docker where you have, once you install Docker, so that is a base of Docker where this Docker engine runs, and that will help you to create and run the Docker containers. Okay, so that's a basic simple definition of Docker engine. And what is the Docker container? So Docker container is a live running instance of a Docker image. So when you have your application running, basically we will say a Docker container is running. So that's the live running instance of a Docker image. So image, we will talk about what is Docker image, so that you will understand how a Docker image is created, how your whole application is packaged into an image. So all those things we will discuss. So now what is a Docker daemon? So Docker daemon process is used to control and manage your containers. So this Docker daemon will be the one process which will be used to control and manage your containers. Now let's talk about Docker architecture a little bit, right? So don't worry about why we did not discussed about Docker images and all those things. We have a complete tutorial or slide on that in this tutorial itself, a complete section on that where we'll be talking about Docker images, Docker image layers, how you create Docker image, and all those things. So that's why we did not touch much here. Okay, now let's talk about Docker architecture. So as you can see, I just simply wanted to show what are the different components which we already discussed, right? Now we can see like we have different components. We already told about Docker, right? So there's a Docker server component where where we will be having the base process of like pulling images, managing containers, and all those things will be part of Docker server or Docker engine, those kind of part, right? And what is the Docker API? So Docker API is the one which will be interacting with the different Docker components. So if you, this is the main part of Docker, which will be interacting with the different other components inside Docker. And as simple like Docker CLI, what is a CLI as stand is called command line interface for executing your Docker commands, right? So when we run some commands on your system, for example Linux system, where you have Docker setup, you need to interact with the Docker, right? So if you want to create a container, you need to tell the Docker that I need to create a container. For that you'll be running some command, right? So that is interacted through Docker CLI. So that is where the Docker CLI comes into picture. Now when you talk about Docker server, you can see like when there are different other components like Docker container runtime where you can run the Docker containers and all those things. And it will also talk about Docker volumes, like how you create volumes, persistent storage, and all those kind of thing. And each Docker will have create its own networks and everything. There are different kind of network in Docker where we can use like bridge network or overlay network. So all those things we also will discuss in the upcoming section of this tutorial. And as we mentioned, Docker images, we'll also talk about that, how the Docker images works. So this is the basic components and Docker architecture. So this is a simple definition. I'm not going to go in depth about each components and all those things, but I think as far as the basics and which you want to understand, this is how Docker architecture and Docker components will look like. So moving on, now we spoke about the basics of Docker and all those things. I think you would got a good picture on the containers, Docker architecture, components, and everything, right? Now let's get into the actual hands-on. So let's see how you can install Docker. So I'll be referring a lot of base documents from Docker itself, Docker documentation. So I don't want to show some kind of other tutorials or other kind of reference document. Since Docker have a good documentation, I'll be referring that and to show how to do a lot of things in this tutorial. Okay, and I'll be giving those all references into the video description as well. So now what we do is like I'm going to use a CentOS machine to install Docker. So if you see, I don't have Docker installed on this machine. Okay, so this is a CentOS machine. So if you have Ubuntu or Fedora or some kind of other versions as well, you can refer this documentation where I'll be showing how we can do the installation on Ubuntu and Windows, Mac. We will see all those things like how to do the setup on those machines as well. So let me go to the documentation for Docker. Now you see this link where it talks about install Docker, right? So there are different ways you can do the installation. So one of the way to do the Docker installation is Docker desktop. So now Docker Desktop, previously we used to install Docker Desktop on Mac and Windows, but now we have Docker Desktop for Linux as well. So I had created a video last week where when this announcement came from Docker, I think few days before only, just a week before only, they announced that there is a Docker Desktop for Linux. So I had created video on that as well. So you can see like Docker desktop for Windows is there, Docker desktop for Mac, and Docker desktop for Linux. But what we will do is we can install Docker engine directly. So rather than using Docker desktop, which will be more of like a GUI based system, uh, which will be helpful for Windows and Mac. Most probably some people in Linux also want to use it, but for me I would go for the setup on using Docker engine. Now if you see, we have different kind of operating system, right? It can be CentOS, Debian, Fedora, Raspbian, or Oracle, no, Solus, Ubuntu. So based on if you're using Ubuntu, you can click on Ubuntu. So for example, I'll open Ubuntu. So now you can see it will tell you the pre-request, how you can remove the old version of Docker, right? And how to install the Docker using the repository, like how to run the apt-get update, apt-get install the certificates. Then you can the GPG key, you can use this to add the stable repository. Then you can install Docker engine using apt update and the Docker CE and CLI, that command. Okay, so that's a simple way. So now let me go for CentOS because I have CentOS machine. So I will go for CentOS, and the same kind of commands we need to do it. If you already have Docker, you need to uninstall it. If you going to do a setup for the first time, you just need to follow these instructions. Okay, so we will do this on our machines. Before that, I also would like to show like there is other simple way to do the installation as well. So you can see that there is other way to do the installation using a convenient script. So you can go to getdocker.com and you can use this script. So it's a simple script. You can run it and it will automatically install Docker and set up everything by itself. So that is the other way, like you can just use the script and it will do everything by itself. So whichever you like, you can do it. So in this tutorial, I will show you the hands-on on basic setup using our commands so that you can get used to it. And as I said, I have the tutorial on all those things in my channel. Let me show you that as well. Now if you see this playlist on Docker, I have 49 videos in my channel. So it's give you the complete details on the, as I mentioned, the Docker desktop on Linux or Docker Swarm, and DevOps, CI/CD pipeline, Docker Jenkins, Compose, basic commands, networking, MySQL, persistent storage, Portainer, right? There is a in-depth tutorial on different kind of setup, Docker Stack, MongoDB, Postgres, Docker Swarm availability, right? Would press on Docker, how to deploy. There's the integration with Jenkins, InfluxDB, monitoring Docker, Rocket Chat. It's a huge playlist, how to set up more complicated things as well. But I'll be covering a lot of topics in this whole overall course with different topics which was not covered there as well as a complete course. So you can follow this, and if you want more information, I would ask you to come to this playlist and have a look on there. So now let's get started on our installation. So I will just copy this command. I will run it on this machine. So you can see it's trying to install some content, right? So yum utils. So let's wait for the installation to be completed. So you can see the installation is completed, and let me clear out the screen. So let me add the repo as well. So we are going to add the repo for Docker. So let me run that. So let me see. I think there is a typo error. It should be like that. So now we can see the repo is added as well. So let me clear out the screen. Now you can see, like, there are different other different kind of repos as well. So now since we added the repo, you need to run this command to install docker c, right, and docker c cli, and you can see it's also installing docker compose plugin, which we will see, like, how we can separately install docker compose in the upcoming section. But here what I will do is I will leave docker. I will copy this command and I will run it, even though it may install docker compose, but we will see how we can separately install docker compose as well. Okay, so let me run this. So I will just click yes. So we are in the process of installing docker, and I will skip this installation. I will come back once the installation is completed. The installation may take some time depending upon your speed and how it's downloading the component. So for me, it's still running. It took around 2 to 3 minutes now. So let's wait for this installation to be completed. Okay, great. So you can see the installation is completed. So I will clear out the screen and let me run docker-v. So now we can see Docker is installed, and we can see Docker version 20.10.16 and build some numbers, right? So that means Docker is installed. So if I go to systemctl status docker, now you can see the Docker is inactive or dead, right? So the service is not running, right? So you need to enable the service for Docker to be started. And before that, I will also let me show you, like, there are different other things, like, how to uninstall your Docker. So if you want to uninstall your Docker, you can also go run this command, like cm remove docker commands, right? And you also have the components of your Docker, like images, containers, volumes. All those things will be saved on var lib docker, right? So you can remove those as well. So if you want to remove Docker from your machine. Now let's go to the starting of your Docker. So you need to do start your Docker service, right? So you need to use systemctl start Docker. So now you can see it's Docker is started. So let me check the status. Now you can see Docker is running and it's showing as active, right? Now in order to make sure that the Docker is enabled or running whenever your system is restarted, so I will also do systemctl enable Docker. So it will create a symlink, and your Docker as a service, it will be running whenever even your system is rebooted, right? Now let's see a few other things. So we are set up our Docker, right? And its Docker is ready now for our further part of our tutorial, right? So our Docker setup is ready. Now, as I mentioned, in order to install Docker on Ubuntu, I showed you the similar kind of commands, right? Where you just need to use apt-get update and the same kind of certificate, right? Now, how you install Docker on Windows? So let's go to that. So you can see Docker desktop, and if you go to Windows, you can install Docker desktop. So in order to install Docker desktop on Windows, you need to download Docker desktop as for Windows. And the system requirement is, like, you have two options. What you can do as a WS2 backend, right? So your machine meet the following requirement for install Docker desktop, right? Or you can have a Hyper-V backend and Windows containers. And you can also see, like, you have virtualization enabled, because you should, by default, Docker desktop, what it will do is it will create a virtual machine inside your Windows or Mac, and it will run your Docker setup there, right? So that is the main purpose of Docker desktop. So you can see, like, you need to, in order to install Docker desktop on Windows, you need to download this exe, and you do run the installation. It's a straightforward installation. So you just need to download and install it. So you can see, like, when it prompted, ensure that use WSL2 instead of Hyper-V option. Okay. So once that is done, you will have your icon on your Windows like this, like a Docker desktop. and you can use that to start. One thing you should be aware is the license agreement for Docker Desktop, because in an enterprise environment, if you are having more than 250 employees, or if you're about 10 million of annual revenue, your Docker Desktop subscription is not free. You need to get a licensed version to use this Docker Desktop. Whereas for your personal machines, or if you are a small company with less than 250 employees and less than 10 million of annual revenue, you are free to use Docker Desktop. Okay, so otherwise, you have to go for a paid subscription, and this is when from the August 2020, August 31, 2021. So all this information I already shared as part of my tutorials on this channel. So if you are new to that, I just want you to understand what is the license concept of Docker Desktop. Okay, now you can see once you install on Windows or Mac, you will have this kind of icon which you can click on it, and you can start using Docker Desktop. You can see the whole details are here, like how it look like, what is the user guide, and all those things. So I'm not going to go through this thing again on Docker Desktop. Okay, but we have our Docker set up on our CentOS machine now. So we have seen how to install Docker, right? So we are ready to move on to the next phase. So let's see how to create containers. Okay, so we'll start with the basics of how to create container. Then we will see a little bit more in depth in the upcoming section of this tutorial. Okay, so let's see, like as I mentioned, we have a Docker install. So you have a Docker version, and let me also show you, like we'll talk about all these commands. Okay, what I'm using now. I'm not going to explain those commands for now, but I have after a few minutes of this discussion, we will see all these commands in this section, tutorial section as well. But if you see, there is no containers running. So how you can run a container is like docker run, and let me call hello world. So now you can see it's saying unable to find the image hello world, so it's trying to pull it. Okay, so you can see it's pulling the image, and you can see it has run this message as hello from Docker. So you can see this message shows that the installation appears to be working correctly. So this was the image. So if you write or give a wrong image name, it will not give that details. Okay, let me try to run another container. So I will run docker run nginx. So you can see it's trying to find the latest image for nginx, and it will run it. So let's wait for that to be completed, and let's see how the Docker container will look like. So you can see the Docker container is running now. So you can see our nginx has started the process. So this session, it will be running, and if once I exit that session, for your Docker container will be exited. We will see how to run all these things on the backend. So now if I go to Docker PS, you can see there is a dead container, right? So one for hello world and for nginx. So this is just dead in 9 seconds ago. This one is about 1 minute ago, right? So the containers are here. Let me clear out the screen. Let me get the Docker container again. So you can see I have one nginx and I have one hello world, right? Let me inspect this container. So if I go, I will inspect and I will give this container ID. You can see it gives you the complete details on your container, right? You can see it gives the container ID, when it was created, what is the entry path, the arguments for that, and you can see what is the current state, it's exited, and all those details about what is the image used, host name, different kind of drivers, platform, all kind of details are available here in this container inspection command, right? So you're getting all the details about the Docker container. So this is one of way you can get the whole details about your container, like what kind of IP address it's assigned, and what is the network ID, and all those things are in the Docker inspect command, right? We will talk about more all these Docker commands in the upcoming section of this time, but I just wanted to show you how you create a simple container and how it will look like. Okay, So now we have seen how to create a simple Docker container, right? So we will go in depth on containers in the upcoming type of these slides. So before I get into the more in depth on hands-on, I want to talk a little bit on containers and Docker images. So what is a container and how we create containers, and what is the Docker images, how the Docker image works. So that is something which you need to understand before we get in depth. Okay, so we will start with what is a Docker image. Okay, so to give a short detail on what is a Docker image. So a Docker image is a read-only template that contains a set of instructions for creating a container. So without a Docker image, you cannot create a container, because the Docker image is the place where you will have a whole set of instructions on what is that container or that image will have it, right? Because using that image is what you have to create a container. So the image will tell you like, this is for this application, this is the command which it should run when you create a container. So all those things are defined in this Docker image template, right? So it provides a convenient way of packaging up your application and pre-configured server environment, so that you can use your own private use or share publicly with other Docker users. So what is the benefit of Docker image? So we talk about what is a containers, and before we explain you how containers come to existence, where you can standardize and package your application with the dependencies and all those things, right? So in order to do that, the image, Docker image, is the best way to do it, because you put your all applications pre-configured, your server details, you put your configurations, put your scripts and everything together, and you convert into that image, and you can use that image as your private own image, or you can put it to some kind of repository as a public, so that other Docker users also can use your applications. So that is how Docker image works. So now we can see how Docker image works. Will be like, you will have a Dockerfile. From there you will build a Docker image, and using the Docker image you will run Docker containers. So that's how Docker overall process of a Docker lifecycle of a container, right? It will create it from a Dockerfile. It will be on Docker image. You create a Docker image from Dockerfile, then you use the Docker image and run a Docker container. Okay, so now let's talk about the anatomy of a Docker image, right? So as I explained, once you create a Docker image, you can run it as a container, but the Docker image is the place where you'll have all instructions, right? So a Docker image is made up of a collection of files that bundle together all the essentials, such as the installation, application code, and all those dependencies of your application to run is in a Docker image, which will be put into a descriptive model. Okay, and you can create a Docker image by two methods. Okay, one is like a interactive method, where creating an image from a container. So if you have already a container, you can convert that container. Using that container, you can save it and you can convert it into a Docker image. So that is one way of doing it. There is the other way of, or the normal way of doing our containers or a Docker image is using Dockerfile. So Dockerfile, what you are going to do is you are using it as a using a plain text file that provides the specifications. So you are going to use a file where you'll be defining the details of the Docker image, what should look like in this Dockerfile, and using that Dockerfile you will create a Docker image. So that is the normal way of doing, like you have a defined set of instructions for your you're creating a Docker image in the Dockerfile. Okay, so what we'll do is, once the Docker image is created, what will happen is it is actually created into different layers, because what we defined as part of this Dockerfile, it will start creating different layers when you build a Docker image. So all these layers forms a series of intermediate images, right? So each layers will act as the intermediate images, and it is built one on top of the other in a stages. So each layer is dependent on the layer immediately below it. So what will happen is, for example, you are creating an nginx or Ubuntu or some kind of image. So what you will do is you will use the base image of your Ubuntu, and you want to install something on it. So you will run a next layer for like installing ABCD, and you will put a third layer, like you put some configuration like XYZ. You put a fourth layer, like I want to entry point, like when you run this application, this web page should open. So there is a different layers you are putting up, and each layer is dependent on the previous layer. So that is the basic anatomy of a Docker image. Now let's see the Docker images layers a little bit more. So there are two kind of layers. One is the image layer, another one is the containers layer. So let's talk about that. So what will happen is, I'm taking an example. So you have a base layer for Ubuntu. So let's consider that's the parent image. So we will talk about more about this, why we need base layer and all those things in the coming section of this, because we have a detailed topic on Dockerfile, how to write Dockerfile and everything. So let's see, this is the base layer for image for Ubuntu. What we are doing is we have a second layer for updating the package. So in our Dockerfile, we'll be writing like update the package, so that will be created as a second layer. Now we will have a third layer for installing our application. So we have a command in our Dockerfile telling that you need to install this application. So that will be created as a separate layer. And the same way you can have different layers, like adding source of your application, entry point, and all those things you can create. So once you have all layers created, and our final or the top will be like a thin writable layer, which will be created whenever you create a container. So this is a writable layer, and it's a container layer where using your Docker image. When you create containers, you will create another layer for writing your container layers. So that is how the normal structure of our Docker image layers will look like. So you can see like how Docker containers will run using our Docker image. So without Docker image, you cannot run a Docker container, right? And in order to create Docker containers, you need to have a Dockerfile. So we will see all those things on hands-on. Before that, I just wanted to give you a clear picture on how the Docker image works. So we spoke about Docker images, right? So let's see a little bit on hands-on there. So if you see Docker images, if I run it, I can see there are two images on this Docker, which is one for Nginx, one is for Hello World, right? And we also seen how to run a Docker container using this Docker image, right? You run Docker run and call this image, and we can add a lot of other arguments and everything, which we will see. But in this side, if you see Docker image, right? Now how you remove a Docker image, you can use Docker RMI, and you can use this image name, and it should be removed. Okay, so unable to remove the repository reference, so you can use it. I will go with this reference number. So okay, I think it's unable to delete because image. Okay, I will force it. So you can see it has been removed. So now if I go to Docker images, I have only one Docker image, which is Nginx, right? Now what I want to do is I will use history, and I will call this image ID. So now if you see, it's giving a big layer of things, right, which we discussed, because an image is containing different layers. Now you can see this is one layer, this is second layer, third layer, fourth layer. There are different layers for this, right? So now you can see different layers. You can see here it says cmd bash. It's you are setting some environmental variables here. You are having some group addition here, some copying some files here. You are having some entry point. You are exposing some port, right? So all those things are here. So one of the things you need to be careful is, like, when you create an image, you should not have some kind of personal details or some kind of passwords. Those things should put it in your image without encryption, because when you have this history of your image, if some data is listed here, it will be visible for everyone as well. So you have to be very careful when you are putting something in your Docker file and you're creating your Docker image. Don't do any hard coding of your username, password, or anything. Encrypt and all those things and put it into your image. So that is one way to do it, because otherwise your all details, all your image, which will be visible for others as well. So we will see more about creating Docker containers, how to use Docker images, how to use build your own custom Docker image, how to push that to Docker Hub in the upcoming part of this tutorial. So I will move on to container registry, because Docker image, Docker tagging the Docker image and everything, we have a separate section for Dockerfile. I will wait for that, so you just wait for that topic which will be coming up in a few minutes. Okay, so let's talk about Docker container registries first. So container registries are catalogs for storage of your Docker images, or known as a repository, where you can push and pull your Docker images. So from the container registry is where we can pull our Docker images, or you can push it. So this Docker image container registry, we have something called Docker Hub, which is owned by Docker itself, which is publicly available, where we can push our images and we can pull it. And these images we can keep it as a private, so we alone can use it, or we can make it public for other users can use it. And there are other ways, like you can use self-hosted registries, or you can also use third-party registries like Red Hat Co, or Amazon ECR, or Azure Container Registries, or GitLab Container Registry, Google Container Registry, JFrog Container Registry. So the different third-party registries as well. And you can also create your own registries using Docker registry as well, which I have shown it in one of my videos as well. So if you go to my playlist, you can see like I have a clear videos on how to set up local Docker registry. There is a tutorial on that, and also how to set up private Docker registry using JFrog. So all these tutorials are covered here. So if you want to know more about setting up your private registry or using JFrog, you can look onto these videos. So that is the basic understanding which you need to know about Docker registries, because that is the place where we'll be keeping our Docker images, right? And also we'll be using it for pull and pushing our Docker images. So that's what all details you need to understand. Now let's move on to how we are going to use Docker, right? So in order to use that on your day-to-day basis, you should know a little bit of Docker commands, because we are interacting with Docker using Docker CLI, right? So some of the commands which we'll be regularly using are like Docker versions, Docker-v, or Docker info, Docker pull to pull your image, Docker images to list your image, then Docker RMI to delete your Docker images, Docker run to create your containers, and you can use hyphen publish or -p for putting a port numbers, or Docker container run, or Docker ps -a, Docker start, Docker stop, Docker restart, Docker rm, Docker rm run -name. These are some commands. Now let's see these commands on a hands-on, right? So I will go to the hands-on sections, and we will try to run all these things commands and see what it does happens. So let's get started with the basic commands. So in order to see like your Docker version, you can use Docker-v or Docker version. So you can see your installed Docker on your machine. If you don't have Docker installed, it will say Docker is not available or is not a valid command. So you can see that into your Docker command. You can use Docker info. So it will give you the complete details on your Docker setup. So you can see currently you have 2 containers, right, and both are on stopped, and it's also give you details on your host setup as well, like what is the total memory, what is the local host name, those kind of where your Docker files are there, like var lib docker. So those kind of details will be shown using Docker info. Now basically, when you run a Docker container, it will automatically pull the image if you don't have that on your Docker machine. So in our case, let me go to Docker Hub. So you can go to hub.docker.com, and if you click on that, it should take you to Docker Hub. Okay, so if you don't have a sign in, you need to create an account with Docker Hub, then you need to log in. So in my case, I will log in. So you can see I have logged in to my Docker Hub, and you can see I have one app here, right? And you can also search for app here. So for example, if I go and search for Nginx, it should give the Nginx different kind of Docker images. So it's an official Docker image. There is one from Bitnami, there is from Ubuntu. So there are if I go to Alpine, you can see there is an official Alpine image. There is something called Grafana Alpine. So there are different things. If you click on it, it will tell you like Docker pull Alpine, right? So if you run this command, it will pull your Docker image. So if I go to my Docker machine, if I run Docker pull Alpine, it will download the image from Docker Hub, and it will take that image into your local host machine. So you can see it has completed. So if I go to Docker images, you can see there is one image for Alpine, right? So Docker pull command is used to pull the Docker images to your host machine so that you can use that image and you can run a container. So if you don't want to run Docker pull always, if you run the Docker run itself, if that image is not there, it will be automatically pulled. So we already seen this command of Docker images. So if you run Docker images, it will list all the images in this machine. So if you want to know, like if you have the images to run this container, you can just run Docker images and it will list you all the images which is already pulled into this machine. If you don't have that image, you can use Docker pull and you can get it from Docker Hub or Bitnami or different kind of repositories where they have that images. Now in order to remove a Docker image, so if you see like this Docker images uses space on this host. So if you don't want to use these Docker images, you can use Docker RMI and you can use the Docker image ID or the name of image, and it will be deleting that Docker image. So if I go to Docker images again, now we have only one image, right, which is nginx. This Alpine image is deleted. So for that you can use Docker RMI. So if you want to force it, you can use -f. So you can force some of the deletion which is not needed some force option. Now let me also show you, like we have used Docker run command, right? We can use Docker run and we need to give the image name. So if, for example, nginx, if I run it, it has created the container. So you can see when you run a container means you need to use Docker run, and you need to give the container or image name, not the container name, the image ID, so that it can use that image and it can run the container. You can also use Docker container run, because it's not only Docker run, you can use Docker container run and the image name. Okay, so I think it's the wrong image. It should be nginx. Okay, so you can see this time also it has created the container. So it's not only like Docker run, you can use Docker container run as well for creating a container. Now when you run a container, there is a possibility like you need to map the ports on the container to the host machine, right? Because when you customize your image, you will have a port mapped to your application to run, right? So for example, in nginx, it's mapped to port 80. Whereas from the local host, you want to map it to a different port. So in that case, what you can do is Docker run, and you can use publish, and you can use the port number like 80:80 and nginx. So it will map, from your locally, it will map to 8080, whereas inside the container, it will be port 80. So you can also use, rather than using publish, you can simplify it with just p. So you can use Docker run -p port 8080 and 80. So that's the simplest way you can map a container port with the host port. So you can use -publish, or you can use -p. Now if you see, like when we run these commands, the container is running on the same shell instance, right? So it's in the same instance. So if you close that instance of your command prompt, it will be closing that as a connection of your container, right? Now if you want to run the container on a detached mode, what you can do is you can use container run, and you can use a command called -d, or you can use -detach. So these are what it will do is it will run this container in a detached mode. So if I run this, you can see it has created a container, and if I run docker ps to list your running container, you can see there is a container running for nginx. Now how I can access this container, you can use the IP address of your host machine, and you can use that to connect it to your nginx. So you can see this is the host 1083. Now you can see if I run the IP address of the host and port 8080, we are inside the nginx homepage, right? Because from the host the port number is 8080, whereas in the container it's a port 80, which is nginx used. So what you can do is, like if you want to run the container in a detached mode, you can use -d, so that the container will be running, and if you use docker ps, you will see the running container. If you use docker ps -a, it will also show you the dead container. So you can see there are around a few containers which we created, and these are all exited, right? So there is only one container which is up, right? All other containers are dead. So what we can do is we can remove those containers. You can use docker rm. So in order to remove these containers, you can use docker rm and the container id or the container name. So let me use this container id, and if I run it, you can use like docker ps -a. Now you can see there is only 2 containers, right? You can also remove one more container if you want. Before that, I want to show you, like you can see the container has given some random names like Noti, Mirzakani, Gifted Cabbage, right? So these are the names of this container. So what we can do is we can give a defined name from our end itself. So in that case, what we will do is I will stop this container. So docker stop, and I'm going to stop this running container. So I don't want to use that. So let me clear out, and I use docker ps. There is no running container, and if I use docker ps -a, the both containers are stopped. So you can see the names are Gifted Cabbage and Naughty Mercani, right? What I want to do is I'm going to use the same docker command which we used. So you can see docker run -d -p and port 8080, right? What I want to do is I want to give a name. So I will use -name, and I'm going to use this call as nginx web server. Okay, so I'm going to give a name as nginx web server. Now if I run this, now you can see docker ps, there is a container running, and the name of the container is nginx web server, right? So you can give a defined name for your container, so that you can see that container specifically, like this is this container, rather than the container docker itself give a random name. Now as I mentioned, in order to stop the container, you can use stop and the container id, or you can use the nginx web server. So you can see it has stopped the container. So docker ps -a. Now you can see 3 containers stop. One is the nginx web server, one is Gifted Package, one is Nori Mirza, right? Now if you want to start the container, you can use docker start and the container name or container id. So now you can see docker ps, there is a container running, right? So that's pretty simple. You can use docker start for starting a container, stop for stopping a container. You can also use docker restart. So you can use docker restart if you want to restart a container, so that will restart your running container. Okay, now as I also shown you, like if you want to remove a container, you can use docker rm and the container name or container id. Now what will happen is, now it's a running container, so you can remove it. So you need to stop it, then you have to remove it. Other option is you can use docker rm -f, and you can use docker container id. So it will remove the container completely since forcing it. So but the problem would be, like if you force it, you're going to lose everything. So you're not going to save anything, or you're killing your running a container. Okay, and what I also want to show you, like if you go to var lib -docker, you should be able to see all the details of your docker setup. Like you can see the containers, image, network, overlay, plugins, runtime, swarm, temporary, volumes, everything is under this location for your docker setup. So this is the main place where all the docker documents or docker files are saved. So you need to check that if you want to find some data for your docker volumes or containers or image id. All those things will be available there. So we have seen all these basic commands used in Docker. There are more commands, like how to use for volumes, how to use for network, how to use exec command for interactive mode, you have other commands for logs, but I'm not covering that because I'm going to cover those in the later section of this tutorial. Okay, so it's not like I don't want to share it now, since anyhow I'm going to cover it as part of later section of this tutorial. We will cover that in those sections. Okay, now let's get started with the Docker debugging and interactive mode. So as I mentioned, some of these commands will cover here, like how to use Docker logs, how to use IT commands, how to use Docker exec for getting inside to a Docker container. So let's talk about all those things as part of Docker debugging and interactive mode session. So let me run a container on Ubuntu. So it can be like a -d and I, because interactive mode, and I'm going to use Ubuntu and bin bash, so it can run the Ubuntu container. Okay, so let's wait for that to be completed. So now you can see the container is created. So if I run docker ps, you have the Ubuntu container, right? Now how you identify, like some issue happens in your container, you want to understand some of the concept, like how you can get some more information what is happening with this container, so that you can get some details how to fix those, right? So some of the details what you can find is on containers, use docker inspect, and you give the container ID or container name. It will give you the complete details about your container, which I've showed you some time before in this section. So you can see it give you the complete details about the container. Okay, so based on that details, you should be able to see, okay, what is happening to this container ID, where this container image and all those things are saved, what is your IP address of this container, and what is happening with this container volumes. All those things details you should be able to get it here. Okay, so that is one way to do it. You can get docker inspect command. If you want to understand more about docker inspect, you can use docker inspect and help. So you can see it has options, a name, ID, you have -f options, -s type string. So there are different arguments for that, so you can use any of those if you want more information over there. Now again, if I list the Docker container running, now I want to understand what is since this is running as a detached mode, I'm not able to see what is happening on the shell screen, right? So what I will do is I will use Docker logs, and I will use the container ID, so it can give me the details about the what is happening on the container. So for now I think I don't see any information here. Maybe it's not doing anything. So let me see docker logs -f and this container ID. Let me see. I'm trying to use checking the logs continuously, so I'm going to use the -f command to tail this logs. Okay, so maybe this container don't have much information. I can create a container as we do for docker run -p 8080, or I think I have this container already running, so -a, and I think there is a container for nginx, right? I will just start that container. So docker start, and I'm going to start this container. Okay, so we have container 2 running, okay, which is nginx. So let me see docker logs, and let me see this container. Now you can see the container logs are coming, right? So you can see the complete details about this container, like what happened on this creation of this container, right? So all those details you should be able to get in the log, so you should be able to understand what happened to the container or something wrong or something. So you can use docker logs -f and the container ID or the container name to run these things completely. So like follow this process, so it will keep giving these logs. So if something is happening, it will keep updating the logs on the screen. So let me also show you like docker logs and -l. You can see what are the different kind of options you have. So you can see we have used -f follow log output, right? So there is -n number of lines showed, there is -t for timestamp, right? You can also use like docker container logs. It does the same things, like what we did for docker run, it's the same like docker container run. So it's the same commands without without container or no, with container. So you can use that as well. Now let me also show you, like, in the container. Now this container is running on this host, right? Now if you want to understand what is happening inside the container, what you can do is you can use docker exec command, which will allow us to connect to inside your container. So I will use docker it for iterative mode, and I will run this container. So what will happen is the problem is you need to also give an argument. So I will use bash so that it can enter inside the container. So now you see, till this time we were under localhost. Now we have changed to C1B9ACC80CA, which is this container, right? Now if I go and inside that, whatever we are seeing is inside this container, not on our local host. So all these things like docker entry sh, home, lib, everything is under inside the container. So if you have some file or something inside the container, if you want to modify it, you can come here and you can update it. And you can also see like what is happening inside some folder, something goes wrong. So you can use docker exec it, and you can use the container id and the argument like bash or bin bash or something, which is used to connect it to your inside the host. So depending upon which host it's running. So this is also another way you can debug your container. Okay, so from exiting out, you have to exit. So you should come back to your host. So now you're inside the host, out of your container. So now for debugging your container, we saw 3 commands. One is docker exec -it for iterative mode. We have seen docker logs and docker inspect, right? So these are some commands which you can see. You can use it to root cause your docker container issues. You have some problem with the the running containers or something lagging. If you want to find the logs, what is happening, so you can use all these commands and analyze your issues. Now let's talk about persistent data in Docker. This is a very important topic because in Docker we need to understand about Docker volumes and how you can persist your data. So let's try to understand, when do we need Docker volumes. So when we have some stateful applications like databases where we need to store your data, and you want to have some persistent storage, that when the container is killed or it's got stopped, it should not lose the data which you're connected to the stateful application. That is the where we need to have to consider the concept of Docker volume. So for example, you have a Docker engine and you have a container running, right? And you have a MySQL, most probably you can consider it as a MySQL container, and you have a database. So in that case, you will have your data on var lib MySQL data inside your container. So what will happen, like when your container is deleted or something like that? So what will happen is your data is deleted whenever the container is destroyed or stopped or restarted, right? So this data which we are having inside the container, like which gets saved for var lib MySQL data, which is running inside the container for your MySQL, right, where it will store all your database tables, all the data which you need for your application. So that is the case when we consider, we don't want to lose this data related to your application for this stateful kind of cases. So that is concept where we have to bring up this Docker volumes. So what is Docker volumes? So in Docker, containers are used to run application in an isolated environment, right? And all these changes what we do inside the container are lost when a container is stopped or removed. So that is what we discussed, like what will happen if the container is stopped or deleted for this MySQL data, right? So in Docker, we can use Docker volumes or bind mounts to manage your data in Docker containers to solve this issue. So we can use Docker volume, which can be a Docker managed volume, or you can use bind mount. So you can we'll talk about Docker volumes and bind mount a little bit late. So that will help you to solve this problem of your data is getting deleted. So we will see also hands-on how we can create Docker volumes and everything. So this is the scenario we showed, like, you have a host, you have a container running for MySQL, and the data is inside the container, right? Now what we will do is, in order to save this MySQL data from the container, we will attach that path from your container to a Docker volume inside the host. It can be a mount point, or it can be a Docker volume which is managed by Docker. So what will happen in that case, all the data from the container will be stored in that volume path. So even though your container is deleted or destroyed, this volume will still remain in the host, and you will have the data available in that path. So what is the benefit is, like, if you're going to create another container and you map this same volume to that container, your application will have all the data coming from that path. So you don't lose any data which is stored in that location of your volumes or mount point. So in that case, you can use this persistent kind of time. So most probably in in kind of continuous integrations, or high availability setup, you can have this path, so you can have multiple containers running which you can use the same path, or you can have once the one container is deleted, other containers can automatically attach this volume, so your application will run without any problem. So the persistent storage, as we mentioned, we can use Docker volumes and bind mounts to persist the data. So that is the concept of persistent storage in Docker. So now there are different kind of volumes. One is called anonymous volume, or you can have named volumes, and you can have bind mounts. The anonymous volume is like Docker containers itself create some volumes. If you don't name it specifically, like this is the path which you want to attach, and this is the name you want to give it, that's the anonymous volume. But usually we will use named volumes and bind mounts. Name volumes, like when we create the containers, we will mention like the volume name, and also we will map that key value pair. This volume will be attached to the path in the container to this location. And bind mounts, as I mentioned, it uses a specific path in the host, and it can attach to a specific path inside your container. So volumes are the preferred mechanism for persisting data generated by and used by Docker containers. So usually we use volume method, and while bind mounts are dependent on the directory structure and OS of the host machines, and volumes are completely managed by Docker. So let me go to the Docker documentation for managing data in Docker. Now you can see, by all this information what we discussed, it's available already in the Docker documentation. You can see all files created inside a container are stored in a writable container layer, right? And how this structure will happen, as I mentioned, like there are right type of mount which you have to select, whether it's a bind mount or it's a volume. So you can see the containers and how you can attach bind mount or volumes into the Docker. Now you can see volumes are stored in a part of host system which is managed by Docker. So by default, all the Docker volumes will be saved under varlib docker volumes, whereas bind mounts may be stored anywhere on the host system. So it is not managed by Docker. You are attaching a specific path. For example, you can see the file system, you are attaching the path directly to the container. So you can see when we create a mount, we are going to give a key value where you'll be mentioning the source, which will be your some path in your host machine, and the destination or target, which will be another path inside your container. So that's how we created. Now let's see how we can create all those things on hands-on. So let me go to the machine where we have Docker install, and we were using for our previous part of this tutorial where we run a lot of Docker commands and everything. Now in order to see what are the volumes available, you can see Docker volume ls. Now we don't see any volumes available in this Docker. And as we also shown, like the default location is for Docker volume is varlib and Docker and volumes. So this is the place where we'll have all the volumes getting saved when we create a volume. Now let's create some volumes. So you can see Docker volume create, and I will call this as volume 1. Now you can see it has created this. Now if I go and see docker volume ls, you can see there is a volume available, right? So previously it was not there. And if I go to ls, now you can see inside the path, so we are inside the path var lib docker volumes, right? And you can see there is a folder called volume 1. So the volume is created as volume 1 and it's saved under this path, right? So now we can use this volume to attach something on the container, so that the whole data from the container can be persisted to this volume. You can also inspect the volume. You can use docker volume inspect and the volume name, so you can use that. So once you run it, you will get the details on when the volume is created, what is the driver, and what is the place where all the data will be available, what is the name of the volume, and the scope is the local. So that's all details it be given. Now let's see how we can attach this volume to a container. So what I will use, I will create a container, docker run. I'm going to use nginx web server, so I will call the web server, and I'm going to use -v, and the volume name is volume 1, and I'm going to attach to /app, and I'm going to call nginx. So you can see what we are doing is we are running a container and giving a name for this container, and we are attaching the volume 1 from the docker volume, and I'm going to use the path from the nginx container as /app. So let's run this. Now you can see it has created the container and it started the process. Now if you have to check it, I have to exit this because it's not run in a detached mode. I will probably run it in a detached mode, so I will run -d so it can run automatically. So the problem is, like, we already have a container name used as web server, so I will remove that. So docker rm, and I will remove the web server. Let me clear out the screen and let me run it again. Now you can see this container is running, and if I go to the current location is this one, and if I go, we have the volume, and if I go to volume 1 and you have data, if I go to _data, now you can see we don't have any data inside here. Why? Because this is getting from our docker container. So if I go to docker exec -it, and if I call web server and /bash, so it should be bash. Now we are inside the container, and you can see there is there is a folder called app, right? So here it is. So if I go to cd app, there is nothing inside that. So because of that, we don't have any content in our volume itself. Let me create a file. So I will call it as test.txt, and okay, there is no vi, so let me use touch. Yeah, so if you see, I have created a test.txt, and I will exit from here. Now inside this data, you can see there is a test.txt, because whatever we created under /app inside your container, now it's hosted or persisted into your docker volume. So you can see now what we are checking is volume_data, where we can see this file as text.txt, which we just created inside /app, because we have mapped the volume 1 to /app in nginx. So that is the purpose of sorry about that, I had mistakenly closed the session. So that is the concept of docker volume, that you're persisting the volume, the data from your container into your host machine. Now we can also see, like, what we see is like the volume managed by Docker. Now we can also map some path inside your host directly into the Docker volume, which can be used as a mount point. So let me delete this container. So I will docker rm, and I'm going to force this because it's already running container, so it will be deleted. Now the point is, even if you delete container, your volume will not get deleted automatically. So volume is there. So if you want to create another container with this volume, you can create it. So all your data here, it will be automatically mapped there. And if you want to delete the volume, you have to run docker volume rm, and you have to use the volume name so it can delete the content. So the volume is deleted from the machine. So if you see, now we don't have the volume for volume 1. Now let me create a folder here as test. Okay, so we have a file folder here, and I'm going to use the mount point now. Okay, mount point also we can use the normal volume created from you can create a volume and attach that, or you can map directly to some path. Okay, so what we will do is let me run docker run again, and -d, and I'm going to call this as again as web server, and I'm going to use -mount, and source equal to, I will call as /test, and destination equals /app, and I'm going to call as nginx. Yep, so what we need to do is like we need to change the destination as a target. So sorry about that. What we need to do is we need to put a comma here, so it should be like source then comma target. So I think it's invalid character. Yeah, so what we need to understand is like we got some errors, right, when we create the bind mount. So in bind mount we have a different kind of types. So one is like a bind type, or other one is like a normal Docker type. So that is where if you don't specifically mention it's a bind mount, then it will try to find the normal Docker volumes. So what I will do is I will docker run and -d, and I'm going to use name web server, and I will use mount, and what I want to do is I want to give the type equal to mount. Okay, and then comma, and we need to give the source, and the source equal to /root/test, and I have to give the target equal to /app, and I will call nginx. Sorry, the type should be bind, not mount, so it's a typo. It should be bind mount, so it should be bind. So I will run this. So now you can see the container is created. So if I see the container is running, so what we did is like we created another web container where it's the mount point, and I'm going to use type bind, and the source is /root, and target is app. So we see that we have a file called test. So if I go test, and if there is nothing inside that, let me go to inside the Docker. So docker exec -it, and I'm going to call the web server, and I'm going to get inside. Now again I have a file called /app. So if I go there, nothing inside there, right? So I will create a file called testserver.txt. Now you can see there is a file here. I will exit from here, and we are currently inside the folder test. Now if I see, I have a file called testserver.txt inside our test folder as well, right? So this is how we can do a bind mount. Whereas if you want to use a normal Docker volume, even in the -mount, you can use a normal Docker volume. How you can do is the same way, like you just need to change the source to the normal Docker volume. For example, let me clear out this screen, and let me delete this container docker rm -f, and I will create a Docker volume create mount volume. So it has created a volume, okay, called as mount volume, Docker volume ls. So you can see mount volume. Okay, now what we can do is same way like docker run -d -name web server, and -mount. We can use this source equals the mount volume, comma, and target equal /app nginx. Now it has created a same kind of container where we use -v and we have mapped mount volume to /app, right? So this time it is using Docker managed volume. So it's pretty simple. So but you need to understand the concept of creating Docker volume, because it's very important in Docker concept, where you need to do a persistent volume, or you need to save your data and it will be used in different places, like how to reuse those volumes attaching to different containers and all those things you should understand. So that is all for this volume part. Now let's get into the next topic. So let's move on to the next important topic, is Docker networking. So networking in Docker is really important for you to understand what are the different networks available in Docker, in what cases we use. So it's a really important topic. So we will go through the hands-on how the Docker networks are created, how we attach the networks, all those things we will see it. So what we have to understand is Docker takes care of the networking aspect, so that the containers can communicate with each other containers and also the Docker host. So the Docker itself has all these features where it will create all different kind of networks, and it will communicate with the hosts, the containers, and all those things. It will be done by Docker itself. Now there are different kind of networks. So one of the default private network created on the host is called bridge. So that is the main one which we'll be using to communicate with containers and all those things as a bridge network. There is also a host network, which is specifically which we will use when we create a container, and if you attach a host network, then it will be directly using the host network. And there is also an overlay network which is specifically for using for Docker Swarm kind of setup. And we also have a MAC VLAN, so where we can create a network where we can attach a specific MAC address. And there is also a network called none, so which we can attach to a Docker container. So that means the container will not have any network at all. So let's go through this a little bit more. Like, containers on bridge network have an internal IP through which they communicate. So that is what the thing about the bridge network. So where we have host network, it utilizes the host IP address and the TCP ports, and disable the network isolation, because it uses the host IP address itself. So it's it will not give the isolation between different containers kind of things. And we have this non-network driver. These containers will not have any access to external network, nor able to communicate to other containers if you use non-network. And this overlay network, we can communicate with multiple Docker daemons together, and it's mainly used in the Docker Swarm services to communicate with each other. And MAC VLAN network allow you to assign MAC address to a container. Now let's go to the Docker documentation on networking. So you can see the complete details about the network drivers are here, like what is the bridge network, which is the default network driver, and it's allowed to usually used when your application runs on standalone containers and they need to communicate. And you have the host, which we discussed, overlay. There is also something called IP VLAN and MAC VLAN we discussed, non-network, right? So all these networks are described in the Docker documentation as well, which you can have a look. Now let's go to our hands-on. So we can go to our Docker machine, and we will try to see a little bit about the Docker containers. Now if you go to Docker network -ls, you can see the different networks available by default. So you can see there is a bridge network, there is a host network, and there is a null network, right? Now you can also see this if you go to IP addresses which you have, you can see there is already one Ethernet or the network created called Docker 0. So this is also created as part of the Docker installation, which uses for communication. So let me create this, clear the screen. Now in order to create networks, we can use Docker network create, and I'll call it as mynet. So it has created a network. So if I go to Docker network ls, it will list a new network, and you can see by default it has used the driver called bridge, right? So I have not specifically mentioned which driver it has to use. So if you don't mention anything, it will default take the bridge driver, which is the default one. Now if you want to specify which driver you need to use, you can use Docker network create, and you can use hyphen driver, and you can mention your driver. So I will use overlay and I will call it as my over. So you can see this node is not a Docker SOM, so use Docker init to connect. So means this overlay network can be created only if the Docker SOM is enabled. So in normal cases you cannot use overlay network. So once you install Docker SOM, once you configure Docker SOM, by default it will allow us to create Docker SOM. Even if you want to use some other networks, you can use like none. Maybe I will try none. Let me see. So I'm just trying to create a different driver. So let me try to change to a bridge. So by default it will create bridge, but if you want to specifically mention bridge, you can use as a driver name itself, my bridge. So you can see it has created a network called my bridge, right? And it has used the bridge network. Host network we cannot create one more because there is only one host network allowed. Let's try with null. So it's not none, it's called null. So let me use that, and my null. Yep. So in the null network also, it is only just allowed only one instance. So since already there is one, you cannot recreate a host or null network. And now if you see, like we already have two network, right? So if you want to inspect this network, you can use Docker network inspect, and you can use the network name. So now it will give you the complete details on what is the network name, what is the ID, when it was created, what is the driver, it's a bridgenet type of driver, and what is the IP assigned, like what is subnet, what is the gateway, what is the internal things, configurations for that. All those details are available in this, so which will be helpful, like what kind of subnet, gateway, and everything is assigned for this network. Now let me clear out and Docker network ls to display. Now if you want to delete any of this network, you can use Docker network rm, and I will delete this my bridge. So I will delete this, so that network is deleted. Okay, so you can see that my bridge network is deleted. Now I have only my net network which I have created. Now how would you want to attach a driver, right? So basically when you run a normal Docker container like docker run -d name web server and nginx, it will create a container and it will use this default bridge network. Now let me run this and let me show you. So if I go to Docker inspect, and if I check this container web server, it will show you like which network it has used. So you can see we are, let me see, we are this content, let me say where we are talking about network. So now if you see, if you go down, it is using the bridge network, right? So the name of the network is bridge, and these are the IP address, gateway, and all those things it is using from this network, right? Now if I want to use a different network, what we have to do is we have to attach that network to the specifically mentioned that when you create the container, it has to use this network. So I will remove this container, and I will use one of our Docker network ls. So we have this network called mynet. I want to use that network when we creating the container. So I will use docker run -d -name web server, and I will have network, and I will call as mynet, and I will call the image. Now this container is created. Now if I inspect this container, you can see this time what we are using is the network is mynet, right? So this container what we are running from Docker inspect, what we are seeing is this time this container is using my net. So same way, like when you create multiple containers, if you want to isolate them between different network, you can map that, I want to use all these containers on this mainnet, other rest of containers on bridge. So those containers which are on a specific network will be isolated from the other networks as well. So let me clear out. So that is a basic concept, like you create a network and you can attach that to a container, so that all those containers will be on one kind of network and other containers may be on a different network. So I will remove this container. So what we have seen is like about the containers, how to attach a network. So this is directly using our CLI command. Now we also have an options to add networks, volumes and everything using Docker Compose file, where we can define the YAML file where we'll define all this network volumes and everything, which we will see in a later part of Docker Compose discussions. From a networking point of view, what you need to understand about this network is bridge, overlay, host, none networks. Basically how when you're using this overlay network, we will also see when we create a Docker Swarm setup, so we can see how Docker Swarm is set up and how the overlay network is created, and that will be used as well. Now let's talk about a Dockerfile. So Dockerfile is also an very important topic as part of Docker tutorial. So we spoke about Docker image, right? So we seen how we can pull image from Docker Hub, how image can be used to create containers. But Dockerfile is an important concept where we need to learn to know about how to create our own images. So let's discuss about what is Dockerfile first. Then we will see how we can create custom Docker images using Dockerfile. Okay. So in simple term, a Dockerfile is a simple text file with instruction on how to build your image. So previous sections when we discussed about image and image layers, we have seen how an image will be created, right? So image will be created in different layers, and each layer will contain some data which is given as part of Dockerfile instructions, right? So we'll see how this image will be created, and also what instructions we can give it in Dockerfile in our demo. So this is a sample Dockerfile where I have just shown you like how we can create a simple image using Ubuntu image, and we are giving some command onto that Ubuntu, and we are going to install nginx, and we are going to run echo command at the end of the process. So we'll see all those things in the demo. So, but I just want to show you a sample, Dockerfile. Now, if you see a Dockerfile always starts with from, which means it tells Docker from which base image you need to or you want to use from your image from. So that means always when you want to create a Docker image, you need to use some base image, right? You want to use CentOS or Ubuntu or nginx or Node.js, some kind of existing base image from Docker, and you are going to use that, and you are going to make some update. You are going to copy some content into it. So always your Dockerfile will start from where we'll define the base image. So as I mentioned, Dockerfile must begin with the from instruction, and there are a lot of parameters. So in the example what I have shown you, like a maintainer, so in the maintainer part we can define the person name or the email address, some kind of things where we can define that who is going to maintain this image. So tomorrow someone want to see who is the maintaining person for the image, that is what we can see. And you can use other different commands. So run is one of the command we can use in Dockerfile, and which is used to run instructions against the image. So if you want to run any instructions on the image, we can use run. So you can tell like run yum install nginx or some command which you want to run on the image, we can use run. And you also have cmd, the command specify the instruction that has to be executed when the Docker container starts. So cmd is the command where you will define like when a container starts, this will be the one which will be running as part of the container. And you also have other commands like lot of commands are there which we can use, and I will show you some of my own tutorials which you can refer. So if you go to my tutorial, this playlist, which I will link into this video description, you can see I have the topics on Dockerfile, where we have some classification on entry point, CMD, run. So what is the difference about all these things? So you can refer all these tutorials on this playlist, so which will give you good details on different kind of commands which you can use. Now you can also refer this Docker documentation, where it will explain you about the Docker file and how different kind of commands we can use, and how to build a Docker file, which will build a Docker image from a Docker file, which I will show you as part of our demo, and different kind of commands we can use as part of the Docker file. So you can see the instructions, arguments, run, what we are using. Alright, so on different cases of run we can use CMD, how the CMD have different kind of parameters, like you can use different formats of CMD, and also entry point, which I already explained in one of my video, which you can refer it in my channel. So you can also refer all these things inside this documentation from Docker, where it shows about labels and different kind of instructions. So I'm not going to go in depth, but I will show you some of the basics how we can use. And another one of the main command we'll be using in Docker file is like work directory, and this command used to define the working directory of Docker container. So we can you define like a work directory /app/ something like that. So that will tell that Docker file Docker, when you create a Docker image, that means this is the directory. Now you are going to run all your commands, copying something. So you can refer those things. I will show you like how we have used some of these commands in our custom Docker image, which I also shown as part of one of implementing a Node.js application. So let's move on to create a custom Docker image from our end. So we can go to our Docker machine, create our Docker image using Dockerfile. So let's get started on that. So what we want to see is like let's list out our Docker images. So now you can see we have two images, one from the base nginx, one Ubuntu. So what we will do is we will create our own Docker file. So I will create a file called Dockerfile. So Dockerfile, and I will copy the contents. So this is the content which I've shown as part of sample, like where we are using Ubuntu as our base image, and the maintainer is the email address I've given. And on the Ubuntu image we are running apt-get update, so that the Ubuntu image is updated. Then we are installing apt-get install -y for silent and nginx. So we are installing nginx on this Ubuntu, and we are running as a command echo. So we'll just display this message. If you want to, you can have other options as well, like we can expose the port for nginx, we can run the nginx as, but this is a sample one. So I'll just copy this content, and I'm going to paste this here. So that will be the image. So let me save this file. So you can see the file, Docker file is there. Now in order to build a Docker image from a Docker file, what you need to do is you need to give the command docker build -t. So you can give a name for this image. So I will use as nginx test, and you can give a version as well. So you can give a tag like 1.0, or if you don't give any tag, it will take as latest. And then you need to give the location for your Docker file. So since we are inside the same folder and where the Docker file is there, I can just give a dot. So that means it will look for the existing folder for a file called Dockerfile. So if I run this, now you can see it started creating the image, right? So now you can see what it's doing is, it's running those commands like apt-get updates, all those things it's doing. So we'll just wait for that to be completed, so that the Docker build is completed and our Docker image is ready. Okay. So now you can see the image process is completed. So you can see it has created different layers, like it has created a different process, right? Each each line will act as a layer, so that it creates a different layers as part of its creation. So the first layer is this one, which is from Ubuntu. Then second layer is from maintainer. You can see removing intermediate containers, and it's installing the updates and installing nginx. And you can see the last one is the echo command, and it has completed with the removing some intermediate containers, right? So let me clear out the screen. So if I go to Docker images, you can see there is now one nginx test, right? nginx test, which we created, and the version is 1.0, which we given the tag. Now what you can do is, if you go to Docker history, and if I use this image, okay, let me use the image ID. Now you can see it has shown the image layers, right? So the first layer is this one, the second layer, right, third layer, fourth layer. So it has created all the layers which we were talking, right? So when we create a Docker image, it's create different layers based on the lines of instructions we given in the Dockerfile. Now how we can use this Docker image? It's a simple. You can go and use this Docker image. For example, Docker run -d, and if you want to give some name, you can use some test, and you can use nginx test. So it will sorry, I think it will look for the version as well. We need to give nginx test and 1.0 because the tag we need to give. So now it has created a container. So you can see Docker PS. So it has got stopped. So you can see the image. It's tried to create a container. So now the point here it is, this image what is we just used, it's only available on this machine. It is not available to be pulled from for anybody who want to use, because if you want to use this Docker image for any other machines, you need to have this image in some repository, right, which is accessible for all machines or all other users. So it's up to you whether you want to make it as a private or public. But if you want to use it as to pull it for other machines, you need to push this image to a Docker Hub or some other repository. I will also refer some of my GitHub link where I have shown you some of the sample Dockerfile. Like this is a Dockerfile which I have used for creating a Node.js application, where we are using from Node base image, and we are setting the work directory as the user src app, and we are copying the JSON package.json file to that location, and we are using npm install so that the npm is set, and we are copying the whole content of your application. So you have different contents over here, like you have package.json, service index.js file, test.file. So all those things will be copied into this base location, the work directory, and then we are exposing the port 3000, and we are running nodes index.js. So when you do this, you are going to run an application about your Node.js application, and whatever you have defined as part of node index.js or app.js, whichever server.js, any name you want to give, and you will be able to access your Node.js application. And we are also having a separate tutorial on like how to push the Docker image to Docker Hub using Jenkins pipeline. So I also have this video on that, how to push Docker image to Docker Hub using Jenkins pipeline. So you can refer that as well to have a Jenkins automated pipeline for doing that. But let's do that as a demo here, so that we can manually push our Docker image to the Docker Hub. So what I will do is we have Docker Hub logged in as well, and if you see, I have only one repository, which is for tips for you and Node app, right? Now what I want to do is I have this image Dockerfile, right? So I want to delete the existing one. So Docker images, I want to delete this nginx text, so Docker RMI, I will delete this, and I need to give the tag 1.0, so it will be deleted. Now what I want to do is I want to build the Docker image again. So if you want to push the Docker image to Docker Hub, you also need to set the tag using the Docker Hub ID. So if I see, I have to Docker build and -t, I will give the name as the tips for you, because you need to give the which account you are having, otherwise it will not be able to push to that Docker Hub. So tips for you, I will give it as nginx test, and I will give it as 1.0, and I will call this the base location, or where the Docker file is. I will put the dot. Now if I run this again, now you can see it's trying to create the Docker image again. So let's wait for this Docker image to be completed, and once it is completed, we need to log into Docker Hub from here. Then we need to push the Docker image to the Docker Hub. So let's wait for this to be completed, then we'll do the rest of the process. So the Docker image is completed, so I will clear out the screen. So Docker images. So now we can see the name of the repository is the tips for you in Nginx, right? So this is very important. Like if you don't give this your account detail, then it will not be able to push your Docker image to Docker Hub. Okay. So now what I want to do is I want to log in. So I will use Docker login. So I will give the username, okay, and I will give the password as well. So now you can see login is succeeded, right? So now I am logged into the Docker Hub. So only once you log in, then you should be able to push the Docker image. So now I can push the Docker image. So Docker push, and I want to use this image. So I will this one, and 1.0 I want to push this to Docker Hub. So I will run it. So you can see, it's preparing the push. So it's trying to push this Docker image to Docker Hub. So let's wait for that to be completed. So the benefit is, like, once you push it, you should be able to see this image from Docker Hub, and you should be able to pull this image to any computer. So it's not only in this machine. Once it's available in Docker Hub, which is the repository, you should be able to pull this image to any machine using Docker Hub. And if it's a public image, any users can be able to pull this image as well. So it depends upon you whether you want to keep it as a public or private image. So let's go and see in Docker Hub. So I will refresh this repository. Now you can see there is one more repository, right? Nginx test, which we created, and you can see if I click on it, it should give the commands like how we can push the Docker image or how to pull. You can see the tags. What we have is 1.0, right? So you can use Docker pull and this one for pulling the image, and you will be able to see all the details. And currently it's let me see, it's a public image, so anybody can see this image. So if you want to make this image as private, you go to settings and you can make this as a private, and you can enter the details so that it will make the images private. So you can see please type the name of the repository to make it private, right? So if I click enter Nginx test and make it private, you should see that this repository is made private now. So not everybody will be able to see this image. So you can see it's private. And what we also can see is, like, if you don't want this image, you can just come here and you can delete the repository so that it will be deleted as well. So you can see I will delete it. So the image is deleted as well from the repository. So that's a pretty simple process. So you can create your own image, you can push it to Docker Hub, but you need to have an account with Docker Hub. For that you need to log in and you need to push for that. As I mentioned, I also have this automated using Jenkins. So you can go to my GitHub link, and there is also a video on that. You can refer that, where we have an automated pipeline, like how to create your Docker image of your application. For example, this is a Node.js app where we are logging with a credential for Docker Hub, and we are using git clone to clone our application for Node.js. Then we are building the app using Docker build, and then we are logging again to the Docker Hub using those credentials. Then we are pushing the Docker image to the Docker Hub. So once it's done, we are going to log out from Docker Hub. So same way, like you can Docker log out. So you can log out from Docker Hub. So you can see that we have logged out from Docker Hub as well. But you can use this Jenkins pipeline to build your Docker image by automatically whenever you update your app. So we also covered the topic of how to tag your Docker image and push it to Docker Hub, and also seen like how we can create this all process using an automated Jenkins pipeline. I also have this part of GitLab as well, so you can see like how we can push to GitLab repository, container registry. So that is also possible. So you can use any of those repository. You can also use other repositories like JFrog, or it can be Amazon, or any repositories you want to push it. You can use that based on your need. So this is a very important topic about Dockerfile, how to create your image, how to push it, because basically you need to have your own image created for application when if you want to create or push your or publish your application as a container. So you will always create some kind of image of yours to run your application as part of the process. Now it's time to talk about Docker Compose. So we have seen normal Docker file configurations, creating images, creating base containers, and all those things. Now Docker Compose, it's really important to simplify your applications and how you create multiple containers. So what is a Docker Compose? So Docker Compose is a tool from Docker, and what it will do is it help us for defining and running multiple or multi-container Docker applications. So if you have an application which need for a LAMP stack where we need different services or different containers, right? You may want an Apache, you want to run a MySQL, you may want to have PHP. A similar way, like if you have a WordPress application where you need to have a WordPress container, you may also need a backend of database container. So what will happen is you will have to create a container every time by separate commands. So rather than doing that, we can have a single Docker Compose file, which is a YAML format. So you can use the YAML file to configure your application services. So you can define your services on WordPress, which will define like this image you have to use. You need to define like this a port number. You need to give a name for the containers, or different parameters which we use on Docker run command, right? We can define all those things in this YAML file, and once you run this Docker Compose up, it will automatically create all your containers. So with a single command, you create and start all the services from your configuration. So we basically use Docker Compose up. So once you use that, it will create all the services or a container which is defined as part of the YAML file. So define your apps using Dockerfile, write your own Docker Compose YAML file, and run the Docker Compose up. So you can also use your Dockerfile in this Docker Compose file. So you can create on Dockerfile, and you can mention that as part of the whole process. So it will automatically build the image, and it will pull up that image to create the containers. So Docker Compose up is what you'll be used to create all those services. So this is an example which I'm showing, like we have services for WordPress. You can see the image we are using for WordPress, the port number we are defining, we are using network as an overlay, we are also defining what kind of replication. And the next service for MySQL, where you are using the image, and we are also defining a volume, which is a Docker's volume, and network deploy as a two replicas. Now if you see, we are also using volumes and networks as part of Docker Compose, and how you define it here is shown here. We will see more about this when we are doing the hands-on. So I'll be showing about this file, how we can use that for Docker Compose, how to build your own services using that. So let's get started to that. So before we do that, I would like to move to the process of installing Docker Compose. So basically, if you do a standard installation of Docker, you may get the Docker Compose also install along with that. So because I shown you in the first command, like you have Docker Compose also when we install Docker in that. So if you don't have that, we'll have to separately install Docker Compose, and we'll have to use Docker Compose after the installation for building our multi-container application. So let me show you some of the Docker documentation where let's talk about overview of Docker Compose. Again, as I mentioned, it's a tool for defining multi-container application. It has shown like what are the different common use cases, so how we can use Docker Compose YAML file. This is a sample of Docker Compose file where it uses a WebAS1 service and it's linking to Redis, right? So there are different details over here which you can go through it, and how we can use persistent volumes using the volumes in that. So let's go to the installation of Docker Compose. So the prerequisite for Docker Compose is like it relies on Docker engine, so you need to have Docker install. And then to install Docker Compose, you can have different methods, like for Mac, Windows Server, Linux. So there are different installation process. So now you can see this, it's a simple process. You have to just apt-get update if it's an Ubuntu, or if it's normal CentOS, it should be yum install yum update, or yum install Docker Compose plugin. So let's get started on that. So you can see once the installation completed, Docker version. So let's do an hands-on how to do that. You also have an option to install Docker Compose using binary. So you can use this curl command. So it will automatically use Docker Compose, and it will you can use this command as well. So there are different ways. Basically, I would see, like in my case, the Docker Compose should be already there. So if I go to version, yeah, I think I have used the wrong typo there. So let me check. If I run Docker Compose version, you can see it's already there, Docker Compose version. And the reason for that is because I showed you, like as part of our Docker installation, if you see, this is the command we have used to install our Docker, right? So it's installing Docker C, Docker CLI, container D, and also it's installing Docker Compose plugin. That's why it is install Docker Compose by default. So if someone has not installed Docker Compose as part of the initial installation, you will have to use yum install and Docker Compose plugin. So I can use yum install, and we need to use Docker Compose plugin. So basically you can see it's already have the Docker Compose already installed and latest version, but as I mentioned, if you have not installed it, you can use the yum install Docker Compose plugin, or you can follow the binary way to do it as well. So you can use the curl command, and you can use that as well to install Docker Compose. So it will download the Docker Compose, and you can run this command to give the permission, so then it will be running as well. So once the binary is downloaded, you can just give the permission. So the Docker Compose version, it should be having it. But anyhow, as I mentioned, we already have all those things installed as part of our initial Docker setup itself. So I already have Docker Compose, but I wanted to show you how we can do that separately as well. Now let's talk about building a multi-container application using Docker Compose. So it's pretty important that you need to understand the Docker Compose concept, so that you can define your Docker Compose file, because it will come up in different places, not only on simple Docker Compose. You may also use that as a part of Docker Stack, or if you want to run multiple services from Docker Stack as well. So this is a sample Docker Compose file which I've shown you as a pictorial representation. So what we need to do is we need to start always with the version. So you need to define the version which you want to use in the Docker Compose YAML. Then we always will have services. So services is the what we'll have to define what kind of services you want to run. For example, in this case, we want to run a container for WordPress, and also we want to run a container for MySQL. If you want to add one more container, you need to define one more services for maybe PHP or Node.js. So that will be another container where you can define. So the name, you can give any name for the services, but the image, you should define what image you want to use, and you can use the port, what port from the host it should map it to the container. You can also define your network. So as we discussed upon the network part, like we can create a network and we can attach to that container, right? Since now we have multiple containers, we can create a network and we can define that all these containers should attach to same network. So you can see in this case we created a network overlay, and all these networks are all these containers are attached to same network, right? And we also have image for MySQL. And I also have volumes. So we are defining volumes as db-data, which is the Docker volume, and it should be also attached to the var lib MySQL data, which is the persistent location inside the container which we want to attach to our local Docker volume. And you also have different method like replicator, replicas. So this replicas will be working only most probably in cases where you want to have multiple containers as a replica side. So basically we have to use Docker stack in those cases, where we have a Docker Swarm set up, and we will have multiple nodes running as well. So let's use this. We can create our containers. So you can see also volumes, and you have DB data. We have networks overlays which we define here, which also has to be defined over here. So let's do one thing. Let's copy this content, and I will create a file called docker compose.yaml, and I'm going to insert the content here. So this is our Docker compose file. I'll just save this. Now what we need to do is you have to use docker compose up, and I want to run it as in a detached mode, so I will use -d. So it's you can see what it's trying to do is now it's trying to pull the image for MySQL and also the image for the WordPress, right? And it will create two services, two containers, one for MySQL and one for WordPress. So let's wait for that to be completed. So you can see it has created both the containers. Now if I see Docker PS, there are two containers running, right? I have used the replica only one, so because I don't want to have multiple replica in this machine, because it's not a Docker Swarm setup where I have multiple nodes or run as a services. Now we can see both WordPress and MySQL is also running, but MySQL is exited, right? So if you see the Docker logs -f, and if you see this MySQL container, it has shown like it has exited because you need to specify some of these parameters in our Docker Compose, because you need to specify the root password for your MySQL database, and also some of the other parameters which it will need for basic creation. So this one, there are a lot of environmental variables which we can set. I have different videos on that. So if you go to my Docker tutorials, I have tutorials on Dockerizing Node.js Express, MongoDB apps using reverse proxy, using Docker Compose. You have other lot of tutorials on that which you can refer. So this is a sample Docker Compose file from my GitHub link, which you can refer as part of the tutorial. So if you go to Docker Compose, we have different kind of services. One is for Node.js app, which I'm using the Node.js application to build our Docker image for using the Dockerfile, and I'm giving a container name, host name, ports, using a network called example.net, and it depends upon the MongoDB DB, and we are using that to create a database here like Mongo image, and same way like we are attaching the ports, network, and the volumes, and we are also using nginx for as a reverse proxy. So we are using some configuration for reverse proxy for nginx. So all those details are here, and you can also refer this GitHub link where you can see different kind of files we have used. All those things will be used here to create the Docker Compose file, and you can refer that as well for getting much better. So basically the Docker Compose is what we need is for creating a multi-container application. So you can simply use Docker Compose up, and you can have all those services or containers running in a single command. Now if you want to down or delete or not delete all, stopping all the containers, you can use Docker Compose down. So it will remove all those containers and networks and everything. So you can see it has done that as well. So you can use Docker Compose up and -d for running in detached mode. If you just want to run in the same shell, you can use Docker Compose up. Okay, great. So now let's talk about more in-depth topic and advanced topic on Docker Swarm and Docker Stack. So if you see like a normal tutorials or free tutorials, they never talks about in depth on topics what we covered here, but I'm trying to cover as much as possible in the short period. So I will also cover this topic on Docker Swarm, why we need Docker Swarm, how to set up Docker Swarm, and we'll also touch a little bit on Docker Stack. So let's get started on Docker Swarm. So what is Docker Swarm? So you may have to understand why we need Docker Swarm. So Docker Swarm is a cluster of Docker engine, and that is what it is called as Docker Swarm. So basically what we have seen so far is a single node Docker engine, right? We have one machine where Docker install, and we are creating the containers, we are creating all those things on the same machine, right? So what is the case where you have a master slave setup, right? So where you need to manage different nodes of Docker, where we can distribute the containers into different nodes. That is where we come up with the concept of Docker Swarm, and it is basically needed for this microservice architecture when you need to work on different project components on different machines, and you need to have a master slave architecture where the master controls the slave nodes, right? So you can similar like in Kubernetes, right? If somebody has known Kubernetes, it's a little bit next topic of Docker, which I'll be creating tutorial on Kubernetes on full course. I already have other tutorials on Kubernetes and single videos where you can refer in that playlist. But same way, like it's an orchestrational tool which allows you to manage multiple Docker containers deployed into different machines, and this will help us to distribute the load on different nodes, and you can run your application or containers on different nodes, and easy for you to do high availability, making downtime, so that you can move one container from one node to other. So automatically those things will be done by Docker Swarm itself. Like if one of the node is down, it will automatically move the containers from one node to other nodes, and all those things it will be done automatically. So as I mentioned, it helps in automatic load balancing while allowing you to leverage the power of Docker containers and guarantees the service availability. So basically, if you run multiple replica of your application, and you will have one container running on one node and other container running on other node, what will happen is, if you have one node down also, what will happen is Docker Swarm automatically move the replica. If you have set replica of 2, it will move the nodes, the containers running on the failed node to different nodes, so that your application is always running in a high available setup, and Docker Swarm will do the automatic load balancing, like all those containers, which node it has to run. Now let's get into setting up your Docker Swarm cluster. So we will see how we can set up a Docker Swarm cluster, and how we can create services, how we can set replicas, and all those things we will see in hands-on. So for this process of creating Docker Swarm, I'm going to use Play with Docker, which is a lab from Docker. And why? Because it's easy to create multiple nodes in Play with Docker. But whereas if you want to set up your own Docker Swarm, no problem, because I didn't want to spend too much of time creating multiple Docker engine and attach it together. This was much easier for me to show you like how we can create multiple nodes. So but the process Docker installation you already know, so you just need to set up 3 Docker engines, and then the remaining process will be as we see here. Okay, so in order to log into Play with Docker, you can use your Docker Hub ID. So I already have a Docker Hub login, so I will just use that to log in. So once you log in, you can see what we are seeing is we are creating new instance. So new instance means this is a Docker engine. So I will create 3 systems. So node 1, and it's creating node 2. So let's wait for that to be completed. So there is some error in the node 2, maybe I will delete it and I will recreate a new one. So now you can see like I have created 3 nodes, the node 1, node 2, and node 3. All these nodes, if you see, it's a Docker engine, so you can see it's Docker install. So simply if you have own setup like in cloud or other place where you have Docker setup, that is pretty simple. Like that is what we required for this whole setup. You just need how many nodes you want to set up. Like if you want to have a single master, one single slave, you just need 2 nodes. If you want to have a single master and multiple slaves, you can have as much as node. Now I want to make this node 1 as the master. So in order to set up a Docker Swarm, what we need to use is we need to use Docker Swarm init, and you need to mention the IP address for advertising, which is the master. Okay, so Docker Swarm init will initialize the Docker Swarm, and then we need to define the IP address which we are advertising for the master. So we need to use advertise -addr and the IP address of your masters, which is 192.168.0.18. So if you just run it, now you can see Swarm initialize. The current node is the manager or master, right? And in order to add the worker to this Swarm, run this following command. So you need to copy this command. This is something which you need to copy it and keep it, so because this command is required to add other nodes as a worker node. So inside your play with Docker, you can use Control and Insert to copy this command, and to paste it you can use Shift and Insert. So your normal Control C and Control V will not work inside the play with Docker. So you use this command like Control and Insert for copy and Shift plus Insert for paste. Now if I run this in the second node, you can see it has mentioned that this node is joined as worker. I will run this same command in the third node as well. Now you can see this is also added as a worker, right? Now let me clear out this screen. Now if I go to Docker node ls, now you can see we have a Docker Swarm setup. Node 1 is the leader or the master or manager, and we have 2 other nodes, which is the worker. You can see all of the nodes are ready. Now now you see like we use that whole command to add the worker, right? Now in case if you miss that code, you can get it using this command. You can use Docker Swarm join token worker. So this will give you the command which we have used to add the worker. If you want to add other node as a master, you can use join token the master. So this will give you, okay, I think it's not master. Need to run as manager, okay, not master. You just need to run Docker Swarm join token manager. So this will give you the command to run another node as a manager or master. So that way you can get the code if you lose that code. So you can see Docker node ls. Now we can see 3 nodes Docker Swarm is set up, right? If you want to add more node, you just create another node and run this command, whichever you want to set as master or worker. So it will automatically add that into the cluster. Now we can create now the service in the Docker Swarm. So what we have to do is we need to use Docker service create, and we need to give a name for the service. I'm going to name it as web, and in the same way like how we use for Docker container, we are setting the ports from the host and also to the container. And you can also use the replicas, like how many replica of your container should run. So I will put as 3, and I will use it as a nginx image. So I've just run this to create a service. And you should run all these commands on the manager or the master, so that it will automatically distribute the load onto the nodes, and it will do the automatic load balancing. You can see it's preparing the services, right? So it's pulling the image, and now it's trying to prepare the 3 tasks, right? The 3 tasks mean 3 replicas it's trying to create. So you can see it's completed. So all 3 tasks are completed, right? So now if you go to Docker service ls, now you can see we have this service running as a web, and it is replicated 3 out of 3, right? 3 containers are running for this service, and it's using the image in nginx. Now when we access Nginx through our portal of port 8080, which I cannot show you now because this is coming from Play with Docker, but if you are using on your own Docker Swarm setup, if you access through the IP address and the port, it should connect to any one of those containers. So it doesn't mean like it has to connect to which one. It will automatically load balance based on the access. It will connect to the containers. Now if you see Docker PS and Docker service PS, and if I use the web service, okay, now you can see it showing me the containers it is running. Right now you can see it has shut down some containers, and it has running other containers, right? So the thing is, like, even one container is not running, it will automatically create the containers on by itself. Now you can see it's running this container, and this container, and see it's all running in the node 1. So it will automatically distribute this load between the container, the nodes which is available in Docker Swarm. If you see Docker node ls, you can see all the nodes are there, node 2, 3, and if I go to Docker service PS, you can see it's running 3 containers. Now if I want to scale this containers, right, now we have running 3 replicas, right? If I want to change it to 5, so I will use Docker service scale, and I will call this service name, and I will call it as maybe 5. So if you see, I just need to remove this space here. So now it's trying to create, you change it that over progress 3 out of 5, right? So it's trying to change those replicas to 5. So let's wait for this to be completed, and then we can check how many replicas are running. So you can see it's almost completed. Now if I clear out this screen, and if I go to Docker service ls, now you can see this replica has been changed to 5, right? So it's it was 3 before, and if I go to Docker service PS and web, and you can see it's running 1, 2, 3, 4, 5 containers, right? And you can see one is running on node 3, other is node 1, this is node 1, this is node 1, and this is node 1, right? So 3 is running on node 1, and 1 is running on node 3, and 1 is running on node 2. So the Docker Swarm itself will define the load balancing and how it can distribute the load on different nodes, and it will take care of that by automatically. So it's pretty simple. Like, if you want to run a high available or services, this is one of the best way, and you can also see how the load can be distributed between. So Docker Swarm is still used by a lot of organizations which are very small setup, which we don't need to have a complicated Kubernetes setup. So Docker Swarm is still a good option for that. Now if you want to delete this service, so you can see Docker service rm, and I will use web. So now you can see you can it has removed the service. Now we don't have any service, right? If you see Docker service ls, there is nothing running there. So it's pretty simple now. So you can just create your own service. So this is an example I showed you with Nginx. You can use your own services based on what is your need, how many replicas you need, how many master node setup you need to set up, what are the different all those configuration. You can set it in your service command, and when you run it, it will create automatically. Okay, we will also see now a little bit about Docker Stack. We'll touch a little bit there. I will not go very complicated in depth, because I already have all these tutorials here in my channel on Docker Stack, Docker Swarm. If you see, we have Docker Stack tutorial, how to write Docker Stack compose file, and how to deploy multiple application using Docker Stack. And we have Docker Swarm microservices using this multi-service voting app. All those things I have already shown here, like update, rollback. All those things are available in this playlist, which I will link into this video description. I would recommend you to refer that to get more information on Docker Swarm and Docker Stack. And as I mentioned, you can use play with Docker playground, play with Docker, which it's pretty easy for you to create for this testing. But as you see, like, if you have your own setup, you can just start using that for your learning on Docker Swarm and Docker Stack as well. So I will just delete these instances so that we can clean up the sessions which is running on play with Docker. So I will just delete that. Now we will get moved into the next topic, which is Docker Stack. Now we are moving to the final section of our course, which is Docker Stack. Okay, so what we are going to do is we'll talk a little bit about the basic of Docker Stack, and also we'll show how the Docker Stack samples, but we'll not go too in depth on Docker Stack because I have separate videos on Docker Swarm, Docker Stack, everything in my channel, which you can refer there. So in Docker Stack, to understand what is Docker Stack, so Docker Stacks allows for multiple services which are containers distributed across a swarm to be deployed and grouped logically. So basically what it says is we've seen Docker's compose file, right, where we define the YAML file where we can club a multi-container application using different services, right, where you can write MySQL or Nginx. So those things, same thing, what we can do is what Docker Stack. So what we deploy in Docker Swarm, you can define your all details as a Docker compose file, and you can define your replicas and all those things in that. So then we can deploy that as a Docker Stack in Docker Swarm. So once you deploy it, it will automatically create that. So the services run in a stack can be configured to run several replicas and which are the clones of underlying containers. So you can have multiple replicas as part of Docker Stack. And to get a stack up and running, you just need to require a Docker Stack or Docker Compose file, which is a YAML format. You write all those things and you just run Docker Stack deploy and that Docker Compose file. So it will deploy all the services and the configuration which we define in the declarative format. Now the deployment of many communicating microservices where Docker Stacks come in. As we saw in Docker Compose file, we define multi-container application where it's interconnected, right? You connect one container with other one where you don't have to create manually each containers. The same way in Docker Stack, your deployment of many intercommunicating microservices is where Docker Stack come in. So let me show you a simple Docker Stack which for MySQL. So this is from my GitHub link. As I mentioned, you can refer this video for Docker Stack, which is I have clearly defined how we can deploy Docker Stack of different applications. So you can see this is similar to what we have defined as part of Docker Compose, where we'll have different services like MySQL. We have this image, we are using the network, and we have a volume. And last time I showed you in MySQL we were missing a lot of environmental variables which was failing that container. So you can set up these environmental variables. These are samples, but I would prefer not to hard code these passwords here. You can use some encryption method, so you don't have to hard code the passwords in this YAML file. And you can see the deploy side, we are going to define replicas. So we are going to define 2 replicas here, so the Docker Stack can create 2 replicas of your service which can be distributed across different nodes, right? And you can also label it. You can also use the restart policies. You can have a different service called visualizer, which is another from Docker, which you can see how the services are running in the Docker Swarm. So it's a simple YAML file. If you deploy this, it will create different services, one for MySQL and one for visualizer. Similar way, I have other one over this GitHub, which is for Nginx. You can see this is where having one service for Nginx, one for visualizer, right? And so you can define your replicas, and you can deploy it to the Docker Swarm. Now if you see, it's there is one point here, it's called constraint, right? You can also define which service should run on which nodes. So here if you see, this is a constraint, like this service should run only in manager node. So this visualizer container will run only in the manager node. If you want to run it only on other nodes, you can define that as well, so that the manager node is not used. Similar way, you can define all these things, and once you deploy it, you will be able to see the services which we already see in the command, like Docker Service PS, Docker Service LS. You can see the details of that where it is running, and the Docker Swarm will automatically do the load balancing and availability of your application based on the replica. So I want to conclude this topic. So this is a long tutorial where it took a long time to complete it, but I would request you like you don't have to completely watch in a single stretch. If you don't have time, you can pause it, you can save this into some playlist, you can watch whenever you want to see it. So we had completely covered the basics of Docker, and not only the basics, we had done the intermediate and advanced level as well. So basically, you know, if you see some of the Docker tutorials, it will not cover all these topics which I have shared it for completely for free, because most of these things they would like to have it like a paid course where you need to pay and do these tutorials. But I'm trying to share it with the community as much as possible so that we can share this knowledge to all of every community members. So just to reiterate, we covered what is containers versus virtual machines, what is Docker, setting up Docker on Linux, Windows, Mac, running your container, all those things we have done. What is Docker image, Docker registries, like Docker Hub, Docker, some of the Docker basic commands, how to debug Docker containers, Docker volumes and persistent storage, Docker networking, the Dockerfile concept, how to create your custom Docker image using Dockerfile, how to push this image to Docker Hub. We also spoke about Docker Compose, how to build a multi-container application using Docker Compose, installing Docker Compose. We also seen how to set up Docker Swarm, setting up Docker Swarm cluster with one master and two nodes, how to create services and how these services are distributing the loads between different nodes, and we also seen the Docker stack details. So that is all for this tutorial, and I hope it is an informative tutorial for you. So I would request you, like, if you are new to my channel or if you have not subscribed to my channel, click on the subscribe button, and also like my video, share with others, and give your support, give your feedback in the comment section. I would try to reply as quick as possible. If I don't know some information, I will reply like, we can finding out after researching. So all those feedbacks, just put it in the comment section, and thank you for watching.